Okay, so let's go through these old exams to prepare you for the final. So first, evaluating a function would be something that would be important to know how to do. So first, to evaluate the function f at -1, I look at my graph, I look at the input of -1 and see what the output is. So the answer is 6. When I want to know what is f of 3, well, I draw a line at y equal to 3, because f of x is just y. So y equal to 3 means there are two possible inputs that can do that. At 0, you get 3, and at -2, you get 3. That's why there are two possible answers. Here, when you're talking about to grade test, it takes 30, for 30 students, it takes 5 cups of coffee. So if C is the number of cups of coffee for n students, then G of 30 is equal to 5. And then explain the meaning of G of 27 is equal to 4. It means for a class of 27 students, it requires 4 cups of coffee. So let's find the domain and range, a very important thing to know. Definitely something that is worth looking at. So if I want to find the domain of this, I know that stuff over 0 and the square root of a negative are the two things I will always write down first, because often in this class especially, that's where we're worried about the domain. So what does it mean to have stuff over 0? Well, since I have a fraction, I worry about where the denominator is equal to 0. So I set the denominator equal to 0 here. Then I square both sides. So if you square this side and square this side, you get this. And then you add 5x and you divide. So what this is saying is, for that point, the denominator is 0, so that's a bad point. I don't want 6/5, I want anything else. So that means that you can't be this point, but you can be anything else. So look over here. I also worry about where the square root of a negative happens. So I look at here, I do have a square root, so I want the radicand, or the thing under the radical, to be positive. So I set radicand greater than or equal to 0. I plug it in, I add 5x, and then I divide by 5. So notice you would switch these inequalities if you ever multiply or divide by a negative number. I didn't do that here, so it stays the same. So this is where the radicand is greater than 0. That's what I want. So you're either this or more. So now I need both of these conditions to be true. So where do I do this and this at the same time? Well, they overlap here. That's what they both have in common. So that's why my domain is from not 6/5 just to the right of it all the way out to infinity. So that is my answer. Number 4, look at this and find the domain and range. Well, domain are the x values. So I'm looking at x values. It looks like here, this x value is about 2.5. All the way out to, it looks like it goes as far as you want. So that's the domain. The range are the y values. So it looks like the y values that got used up are from -4 all the way out to infinity. Okay. Notice here I didn't include -2.5 in the domain because there's a hole, and you never include infinity. It is always open. Here I did include -4 because you actually reach that value. All right, so find the average rate of change given a function. Again, another important thing to know. Average rate of change is change in y over change in x. So in this case, it's going to be g of x plus h minus g of x. That's the change in y. And the x's are going to be x plus h minus x. So when you subtract those, you end up getting this. And then you go about plugging stuff in. So when I plug in stuff here, I go over here to my scratch work. Boop, boop, boop. Go over here to my scratch work. And I see that g of x plus h just ends up being equal to all this. So I plug in x plus h in for x. And when I expand, I get that. Right? And then g of x is just my original function. But make sure that I'm subtracting all of this. So I subtract everything. So I put that in parentheses. So then make sure that you're very careful and you distribute this negative. So when you do, that means that minus 3x squared and 3x squared cancel out. A minus a negative is the same as a positive, so those two cancel out. So all you're left with is this, but then you factor out an h out of everybody at the top, and so you get that, right? And there you go. All right, look here, now finding the average rate of change from 0 to 9 on a graph. Again, you must know that the average rate of change is the change in y or the change in x. It's the same as the slope. So in this case, for the graph, I do y2 minus y1 over x2 minus x1. So I guess I need to label them, and the main thing is to just keep it straight. So here, my x1, y1, I'm going to let this down here be my x1, y1. This be my x2, y2. So y2 minus y1 is 3 minus negative 7, which is 10. And x2 minus x1 is just 9 minus 0. Okay, so you get 10/9. That is the slope between the two lines, also known as the average rate of change. Then for these graphs, evaluate these expressions. So if I go f of g of 4, I first find g of 4. So I go to my g graph and I plug in 4, I get an output of 2. So I replace g of 4 with 2. Then I go over to my f graph and find f of 2. Well, on f, I find f of 2. It ends up being 5. Similarly, if I want to find f of h of 2, I find out what h of 2 is. So that means on my h graph, I look at 2 and I get out 2. Right? Boop, 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 boop. Put in 2, get out 2. Well, then I go to my f graph and do f of 2, so I get 5. Then if I look here and I want to know the transformations, always make sure you're working from the inside out when you're talking about transformations. So the first thing I would do is I would go right 2, because we're messing with x. It does the opposite of what you would think. And then we take all these old y's and add 3. That's why it moves up 3. Well, then if I replace all the x's with negative x's, that means any point that was over here and had an x value, I would replace its x with a negative x, so that reflects across the y-axis. Well, then if you take all the old y's and multiply them by 5, that's a vertical stretch by a factor of 5. Here, if I've got a forest fire, this one was a little difficult for students. So if we have a forest fire and it makes a circular pattern, it says in this case, the radius is growing according to this function. This r is equal to 2t plus 1. What is going on with my pen? 2t plus 1. So if r is equal to 2t plus 1, let me see, for some reason my pen is working. R is equal to 2t plus 1. Then what I can do if I want to express the area burned as a function of time, you would just plug the 2t plus 1 in for, over here, you would just plug it in for r, and so you get pi times 2t plus 1 squared. Hey, what's up?
Can I please have some juice?
Of course, I'll get it for you in just 1 second, kid. So 2t plus 1 squared, when you square that sucker, that ends up being our function. So then it wants to solve that. Solve a is equal to 49 pi. So what does that represent? Well, a of r of t, again, is just plug in r of t into our function. So that's where you get 2 pi of 2t plus 1, all that squared equals 49. Well, then you just solve it by first dividing by pi, and then taking the square root, making sure to put plus or minus 7. Well, then you get 2t is equal to 1 plus or minus 7. And so when you solve, t is equal to 1 plus or minus 7 over 2. That gives you 2 answers. 1 plus 7, which is 8 over 2, which gives you 4 hours. Or 1 minus 7 over 2, which gives you negative 3, which doesn't make sense. So it takes 4 hours to burn 49 pi square miles of grass. Okay. Then we look at 19, and it says, look, write a formula for this. Notice we need to think about order. So first, they want us to horizontally stretch by a factor of 3. That means we do the opposite on the inside of what we would think. So instead of multiplying by 3, we multiply by 1/3. Then the next thing they want to do is shift left. So that replaces our x with x plus 4. It does the opposite of what we would think, right? And so our function is absolute 1/3 x plus 4 in parentheses. Then you take that and then you go down 3. So to go down 3, we would then take our old function and subtract 3. Cool. All right, this last one says during the winter, if we want to begin the program earlier, that would be a shift of that whole graph to the left 5. So then if we write it as a new formula, the new formula w, which would be our winter, is equal to the old function f of t, but it's f of t plus 5, because algebraically that would move it to the left 5. Okay, and that's it for that one. I'm going to go charge up my pen, and I'll be back.